We have learned that a frequency distribution is a table that lists data points along with their frequencies. This is a very fundamental way of organizing information. However, it is often the case that the data points have a very wide spread. In that case, a grouped frequency distribution might be more convenient. In a grouped frequency distribution, data is organized into groups or classes. For example, the following set of numbers are grades from a recent test in a history class. Dividing the data into 10-point classes will help to detect trends in the grades. For each data point, we're going to determine the class that it fits into and make a tally mark in the column. And then we're going to count the tallies to determine the frequency. So if we examine the data points, that is the grades on this particular history test, we notice that not a lot of them repeat. Most of the data points have a frequency of 1. So a basic frequency distribution would not allow me to detect trends. However, if we group them into classes, these are 10-point classes, then we can begin to see the trend or the performance of the class on this particular test. Now, if you'll go back to when we were studying finance and we were looking at the tax tables, then we had classes there as well. We were looking at particular tax brackets. If your income fell between two particular values, then you were in that tax bracket. That's an example of a class. So to begin organizing this information, I'm going to take each grade. The first grade is 82, and I'm going to observe that 82 falls between 80 and 89, and I'm just going to make a tally mark for that particular grade. Then 76, the next grade, that falls between 70 and 79, so I'll make a tally for that grade. 94 fits into the last class, 75 into this one again, 57 into our second class. So I just continue going through the data, and I'm going to mark them out as I go to keep up with the ones that I've done and the ones that I haven't done, and make a tally mark with each grade. Now I'm going to pause the video and finish this task. You can do the same, and we'll restart the video and see if our data matches. Okay, that was easy but tedious, wouldn't you agree? Now that we have all of our tallies listed, we're going to count those tallies, and that gives us the frequency. So for the class 40 to 49, we had 3 students in that class. In the next group, we had 6, followed by another 6, 11 here, 9 here, and 5 for the last class. So if we take a minute and we sum those frequencies, we would come up with a total of 40. Now let's make sure that we got all of our students represented here. 1, 2, 3, 4, 5 in the columns. 1, 2, 3, 4, 5, 6, 7, 8. 5 by 8 gives us 40 total students. So everyone has been represented. Now I hope that your numbers also match my numbers. This again is called a grouped frequency distribution. By grouping the data together, I can see the popularity of each class as opposed to each individual data point or grade. One important thing I want to point about the classes is that the leftmost number in each class, for example, this one, the leftmost number there, is called the lower class limit. And the rightmost number in each class is called the upper class limit. So in the case of the class that we're considering, the upper class limit here would be 99. Now remember, the example told us that these were 10-point classes. But 90 to 99, if I find that difference there, it's only a width of 9. However, the class width is found by calculating the difference in any two lower class limits. The number 10 in this example is called the class width. So if I find the difference between two lower class limits, that difference is 10. Therefore, we say that the class width is 10. So make sure you pay attention to that vocabulary as you're working your homework. So frequency distributions and grouped frequency distributions are excellent ways to organize data.